Well, hello, everybody. Hey, here's the plans for the day. If we were together, I would answer any questions that you might have over Section 2.5. I would also go over a skill check with you, but I'm going to save that skill check for next time, because in the very, very near future, possibly the next class, we need to quiz over 2-1 and 2-6. And then what I need to do with you today with this video is I need to cover Section 2-6. 2-6 is over applications of exponential functions, so we'll have to make our own continuous change exponential functions. And your calculator can't do that. I already tried. I also need to talk to you about what's meant by the effective rate and what's meant by present value. How much money would I need to invest today to have a certain amount in the future? So hopefully you got your notes right in front of you. Here's our goal today. We need to write an exponential growth and decay function model, which will look like this: y equal y sub 0 e to the kt. In this model, y is a certain amount at time t. So y represents the amount at time t. So in terms of ordered pairs here in a little bit, we'll have the time followed by the amount that we're going to have. Y sub 0 represents the initial amount, what we started with. E is the continuous change part of it. And then our goal today on a lot of these problems, we'll need to figure out what K is, called the constant of variation. That'll be our goal on all of these. So if you will, look at your first example there, which says a culture contains 125 bacteria with the population increasing exponentially. The culture contains 420 bacteria after 6 hours. Find an exponential model of the form y equal y sub 0 e to the kt to represent the growth function y in terms of time in hours, and then predict the number of bacteria after 10 hours. Well, here's what I'm going to do. Let me figure out what we know. I know initially there are 125 bacteria. So I know that y sub 0 is 125. Sometime later, there's 420 bacteria. So I know that y equals 420 6 hours later. So t is going to be 6. Well, if you look at what I have in my form, I got y equal y sub 0 e to the kt. I have a value for y. I have a value for y sub 0. I have a value for t. We know that e is that 2.718 number. I need to figure out what k is. So let me just plug in some numbers. Y is going to be 420. Y sub 0 is going to be 125. E to the k times 6. And that's another 6. So e to the k times 6. Well, now we need to solve this. So what I need to do is divide both sides by 125. And whatever that is, it's about 3.36 equal e to the 6k now. And then to solve this, I'm going to take the natural log of both sides. So I'm going to have the natural log of 3.36 equals the natural log of e to the 6k. But we know the natural log and e are inverses of each other, so they're going to cancel each other out. So I've got the natural log of 3.36 is equal to 6k. So k must be the natural log of 3.36 all over 6. So that's my k value. And I went ahead and ran that through my calculator for you. So k is going to be approximately 0.202. So that makes my model then y equal 125, the initial amount, e to the 0.202 t. So there's my model. So in this case, it was pretty nice. We were given the initial amount. We just had to go figure out what K is. And then, of course, to answer the second part of this, predict the number of bacteria after 10 hours. I'm going to have 125 e to the 0.202 times 10. I ran that through my calculator already, and I got about 942 bacteria. But that's going to be our goal today. That was kind of an easy one. I got another easy one coming your way, I think. But that's how we're going to attack it. Here's your next one, your second example. In a research experiment, a population of fruit flies is increasing in accordance with the law of exponential growth. Initially, there were 100 fruit flies. So something I know, y sub 0 equal 100. After 4 days, there were 300. So I know that t is 4, and I know that y is 300. So I have quite a bit again. I have 3 things there. So let me go get the model. So I've got y sub 0 equal y e to the kt. In place of y sub 0, I'm going to plug 100. In place of y, let me plug 300. Let me switch that around. In place of y, let me plug, I wrote this backwards here. That's what I did to get in a hurry. I got my y and my y sub 0 there. You probably caught that before I even said anything. So in place of y, let me plug my 300 there. Let me plug my 100 there. E to the k times 4. And then to solve this, let me divide both sides by 100. So I have 3 equal e to the 4k. When I solve this thing for k, I'm going to take the natural log of both sides, which is going to leave me a 4k over here. So k is going to be the natural log of 3 all over 4. And when I ran that through, I had about 0.275. Now I have everything that I need for my model. My model is going to look like y equal 100e to the 0.275 t. So there's my part A. To do my part B, predict the number of fruit flies after 7 days. I'm going to go y equal 100 e to the 0.275 times 7. I'll grab my calculator, run that through. You know I've already done that for you. About 686 pesky flies. So there's what we got so far. These two were nice because they gave me the initial amount. If they don't give you the initial amount, we might have to go get it. So here's kind of another one. Find an exponential model between the points, or through the points, 0, 5, and 8, 2. Hey, when I do this, here's what I got going on. There's some things that I know. My time is going to be 0. My y is going to be the 5 here. My time is 8. My model is 2. Hey, so I know this is a decay model. As soon as it's a decay model, I know my k value is going to be less than 0. So my k is going to have to be negative. And now this one's pretty nice again. I know my initial amount is 5, but at time 0, there were 5. So things that I know, y sub 0 is 5 again. Now I just got to go figure out some other things. I also know when y sub 0 was 5 at time 0. So let me try to use that to go get a model. So let's look at y equal y sub 0 e to the kt. This one won't be too bad. In place of y sub 0, let me plug a 5. I got an e to the kt, but t is 0. And that's going to be my y value. So it looks like my y value is going to be 5. Notice that that really didn't help me any. Because what did it wind up doing? It wound up just telling me at time 0, I have 5. So I kind of did that on purpose to show you what happened if you pick the same point. Let me take this information, though, along with this ordered pair. And that's going to help me find the value of k. So here's what I need to do. Let me use y minus y to 0, e to the kt again. In place of y, let me plug the 2. In place of y sub 0, let me plug my 5. E to the k times 8. Because over here just showed me what it is at time 0. That didn't help me any. Now let me solve this over here. Let me divide both sides by 5. So I got 2/5 equal e to the 8k. 2/5 is really 0.4. So I'm going to wind up having the natural log of 0.4 equal 8k. So my k value is going to be the natural log of 0.4 all over 8. So k is going to be approximately negative 0.1145. And we knew since it was a decay model, my k value was going to be negative. So we knew that was coming. So my model is going to look like this. I'm going to write my model right over here. My model is going to be y equal y sub 0, which is 5, e to the negative 0.1145 t. So there's going to be our steps when it's through 2 points. Moral of the story, if you know your initial amount, take your given data and then come and use the other data. On the next one, I'll show you what happens if you don't know either of them. So if we'll flip to the next one, we're going to look for an exponential model that goes through the point 1, 1, and 5, 5. So after 1 hour, or 1 day, whatever units is, there was 1, and after 5 days, there were only 5. Well, this model is definitely increasing, so I know when I get done here, k is going to be greater than 0. These are a little bit trickier. Since we don't know y sub 0, or we don't know a k value, we have to go find both of them. So to do that, here's what I'm going to do. I'm going to grab the ordered pair with the bigger value first. So the 5, 5. And I'm going to plug it into the y equal y sub 0 e to the kt. And I'm going to set up a little system of equations. You've probably never solved a system of equations like this, so I'm going to show you what it looks like. So in place of y, I'm going to plug the 5. I don't know what y sub 0 is. There's an e. I don't know what k is, but I knew that time is 5. Notice that I have 2 unknowns in here. I'm going to grab this ordered pair also. In place of y, I'm going to plug a 1. In place of y sub 0, I don't know yet. E to the k times 1. So what I did, guys, is I just set up a system of equations. Let me rewrite it for you so it looks like this. 5 equal y sub 0 e to the 5k. And 1 equal y sub 0 e to the 1k. To solve a system that's all multiplication like this, what you do is you divide. So let me come down here and solve this. 5 divided by 1 is 5 equal, I'll show you why. Y sub 0 over y sub 0 cancels each other out. Equal e to the, since we're dividing, we subtract our exponents, 4k. Now notice I just have one unknown. So I need to solve this thing for k. So k is going to be the natural log of 5 all over 4. That's going to be my k value. So K is approximately 0.402. So there's one piece of my puzzle. Now what do you need left? Well, now we got to figure out what y sub 0 is. So you pick either one of these equations, plug in 0.402 for K, and solve it for y sub 0. I'm going to plug it into this bottom equation, because that looks easiest to me. So it's going to look like this. I have 1 equal y sub 0 e to the 1 times 0.402. Now we just got to figure out how to get y sub 0 by itself. So to get y sub 0 by itself, I'm going to have to divide by e to the 0.402. So y sub 0 is going to be 1 divided by e to the 0.402. And when I did that, I had y sub 0 to be approximately 0.669. So my model, y is about 0.669 e to the 0.402 t. So when you have two that you don't know, we have to set up a system of equations. I have another one just like this coming your way. So if that one lost you a little bit, hopefully the next one will clean it up. On to your next one, if you would. This time we're going to go through the points 1, 3, and 4, 15. So remember, this will be my t value, this will be my y value, this will be my t value, that will be my y value. The reason I picked the one with the bigger t value first is so that when I subtract, I'm going to get a positive exponent to work with. So it's going to look like this. I'm going to pick on this guy first. I'm going to set up my system of equations. So I got 15 equal. I don't know what y sub 0 is. E to the k times 4. So I'm just going to list it as 4k this time. My second equation is going to be y equals, so 3 equal y sub 0 e to the 1k. There's my system of equations. To solve it, let me divide, so 15 divided by 3 is 5 equal y sub 0 divide out. E to the 4k minus 1k is 3k. Now I can go get my k value. I'll natural log both sides. So I would have natural log of 5 equal natural log of e to the 3k. So k is going to be the natural log of 5 divided by 3. So k is going to be about 0.536. So I have a k value. I need the y sub 0 value. So pick either equation you want to work with. I'm going to pick this guy because it looks the easiest. So I'm going to have 3 equal y sub 0 e to the 1 times k, so 0.536. To get my y sub 0, I'm going to go 3 divided by e to the 0.536. And when I did that, guys, I got about 1.76. So my model, y equal, so really y is approximately 1.76 e to the 0.536 t. So there's my model. So not too bad. Here's your next one. Time to work on. We just got to go through and get your ordered pairs, and then they set up the same. And then I kind of get something I think is a little easier. In a research experiment, a population of fruit flies is increasing in accordance with the law of exponential growth. There's my cube. After 2 days, there's 100 of them. After 4 days, there's 300 of them. Find that model. But what I need to do is go through and set up my 2 ordered pairs. So I need time first, the number of flies second. So So it's going to look like this. After 2 days, there were 100 flies. And after 4 days, there's 300 of those pesky things. There's my ordered pair. Now we're going to do the exact same steps that we did. I'm going to pick on this term first and set up a system. So I'm going to have 300 equal y to 0, e to the k times 4, so 4k. My other one, 100 equal y to 0, e to the 2k. To solve this system, let's divide. 300 divided by 100, 3 equal. Y to zeros are out of there. E to the 2k. I bet you're getting to be an expert at these now. So k is going to be the natural log of 3 divided by 2, which is approximately 0.549. Now we need our y to 0 value, so pick either equation that you want. I'm going to pick that bottom one. So I've got 100 equal. Y to 0 is what we're looking for. E to the 2 times 0.549. Then, of course, to get y to 0 solved, I got 100 divided by e to the 2 times 5.549. Just make sure you put all that in parentheses there. And when I did that, I had about 889 flies. So my model, y is going to be about 889. Oh, you know what? Let me backtrack. When I ran that part through, guys, I had 33. Must be getting late. I had 33 flies on that. So my model is y is about 33 e to the 0.549 times t. That's my model. Where did I just get that 889 from? I was finishing this out. Then estimate the number after 6 days. That's where I was getting that 800 number. So I got 33 e to the 0.549 times 6. There's where I got my about 889. So that takes care of the exponential part of the lesson. I got a couple of formulas to show you over effective rates, kind of what the banks really use. So I'll walk you through this. This is kind of the easy part. So on to effective rates. So I'm changing gears just a little bit. If you have to pause the video and take a break, you can do that. But here goes the effective rate. Suppose that a person invested $1,000 at 5% interest, compounded quarterly. How much would they have at the end of the year? Well, we used this formula before. The amount that that person would have in the bank would be 1,000 times 1 plus 0.05 divided by 4 for quarterly at the end of 1 year. So 4 times 1 is 4. And we're just going to run that through your calculator. So when I did that, I had about $1,050.95. Okay. Here's what's meant by the effective rate. If you walk into a bank, they usually don't say, and we compound your money quarterly or monthly. What they do is what they post is what the APY is, the annual percentage yield. So here's what it really says. What if I wanted to earn this amount in 1 year? What would my interest have to be on the $1,000 investment? So I'm going to kind of go backwards. I would like to have $1,050.95. I would like to initially invest 1,000, and I got 1 plus R over 1, because we're just compounding it 1, so I'm just going to have 1 plus R to the first. Okay, so if I solve this now, I would divide both sides by 1,000, and then I would subtract 1 from it. So I'd divide both sides by 1,000 and get 1.05095 equal 1 plus r. Subtract 1 from this, so my r value is going to be 0.05095. So the interest rate would be about, if I split this decimal over 2, 5.09. So about 5.1%. So here's what the banks do. Instead of saying that they invest your money at 5% compounded quarterly, what they would show, look at the bank when you walk in the dealer sometimes, they'll say APY, and they'll just give you this number. So instead of compounding, they just tell you, hey, here's what your money would really earn. There's an easy formula for the effective rate that you don't have to worry about how much you invested. The effective rate formula looks like this, E with a little subscripted r. Our effective rate is just 1 plus the interest rate we're talking about, divided by the number of compoundings we're talking about, minus 1. O to the n, minus 1. That'll give me the effective rate. So for this problem, I don't need to know the 1,000 and the 1,050. The effective rate would just be 1 plus 0.05 divided by 4 for quarterly, raised to the 4th power. And if you run that through your calculator, you'll get that about 5.1%. That's the effective rate. I got an easy one coming up for you here. What would be the effective rate at an investment of 2% interest compounded monthly? Well, to get the effective rate, it just looks like this. E subscripted r is going to be 1 plus 0.02 divided by 12 raised to the 12th power minus 1. I'll go back and look to see if I minus 1 on the other one, but I'm afraid if I backtrack on my PowerPoint, it would freeze up. If you run this through your calculator, guys, you're going to get about 2.01%. So not a lot of difference on a small interest amount. But that's our formula for effective rate. And let me move on just a little bit more. Kind of, if you wanted to jot those formulas down, those are our main formulas that we worked through so far. We got our compound interest formula, principal times 1 plus our interest rate over. Our book uses N for number of compoundings. A lot of formulas use an M, but M and N is going to be the same thing. Then, of course, we got PERT. And then the effective rate formula is right there. 1 plus R divided by N to the N minus 1. Then I've only got just a couple more things with you. Let me talk to you about present value, and then I'll be done. Here's what the present value means. How much money do I need to invest today to have this amount that I'm talking about in the future? How much today to have this in the future? So on your example there, says find the present value of $15,000 at 4% compounded quarterly for 10 years. I'm not sure if I got your notes changed, but if I didn't have in 10 years, add that to your example there if you would. Well, here's what we got. I would like to have $15,000. So I'm going to use this formula, the amount that I'm going to have, the principal, 1 plus R over N raised to the NT. That's my formula I'm going to use. I know in the future I want to have $15,000. So I've got 15,000 right there for the amount. I don't know what the present value is. That's what I'm looking for. Then I've got 1 plus 0.04 divided by 4 raised to the power of the number of compoundings times the number of years, 40. And now look at that for a second, see if you can figure out how to solve it. It's really pretty easy. I need to get P all by itself, so I need to divide both sides by this quantity. So my P, the amount that I need to invest right here, right now, is going to be 15,000 over 1 plus 0.04 divided by 4 raised to the 40th. And when you run that through, you better get something less than 15,000. And when I run that through, guys, I had about $10,074.80. So if I invested $10,000 a day at 4% compounded quarterly, in 10 years I would have my $15,000. And I've got one more example like that I'll mention the assignment to you, and I am done. Well, guys, my PowerPoint throws up, so I'm not going to do that last example with you, but it's done just like this example. I also cannot get to your assignment page, but if you look at your sheet there, it says the assignment, all depends on which sheet I gave you. Some of them say assignment in 2012, some of them say assignment in 2014. They're the same. It's on Math Excel, but I need you to go and do number 30, 31, and 32 out of your book. That's some of that driving your exponential function stuff. So good luck with the assignment, and I will field any questions that you have next time I see you. Good luck.